relationship, the values in one table may relate to rows in another table. Microsoft Access is a relational database. So is its big sister, SQL Server. So is Oracle. All of these databases are relational databases. They are called that because the data actually relates to each other. What does this mean? It's a fancy way of saying that there is a connection. There is a connection between tables inside of this database. This is done through keys. A key is something that we're going to call a specific row or specific column. Please, I hope I didn't confuse you. The key is going to be a specific column inside of our table. So columns that identify unique rows in the table is going to be used as our key in order to create this relationship. Understand, these relationships are intrinsic. This relationship, it is going to be an implied relationship, as we're about to see. Each table then is going to have a key. Now, here's something to keep in mind. Each table, except for a specific type of table, is going to have a key to it. There are going to be foreign keys. A foreign key is going to be a key in the other table, in the related table, that is foreign to itself. These are keys in different tables, one in which they reside. And again, you're sitting there, and I think probably some of you are cross-eyed at the moment, and I don't understand, and what is this person talking about? That's all right. I need to first introduce to you the terminology before I actually show you this in action. Because again, now I'm going to be using these terms. Once I'm using them in an example, you're going to understand this better. So right now you're looking and you're saying, what? And can't figure. That's all right. All that I need you to do right now is to know what the definition is, what a key is and a foreign key, and now we'll see it in action. Using this combination of foreign keys and foreign keys, we're going to be able to create then a relational database. A database where the tables are implicitly related to each other. So databases using this and using the foreign keys. Here is what I mean. Here is an example. I have 3 separate individual tables. I have one table here that is a listing of all the emails I've received from students. I have another table here that lists all of the office visits I have from students. And then I have a third independent table that contains all of the data on my students. Now, all of these reside in a single database, and this is a relational database because there's a relationship created between these 3 individual isolated tables, and this is done through a primary key, foreign key matchup. So looking at this, let's start looking at the student table. At the student table, I need a primary key. I need a key that is going to uniquely identify each and every row. By identifying each row uniquely, this means, as you probably already guessed, the data inside of that field must be unique. No other record, no other row can have that same data. So looking at something like this, I'm going to have the primary key of student number because I guarantee student number is unique for each student. Having a primary key, if I want to relate it to emails, and I want to say, all right, how now am I going to relate this? I could have had in my email table, I could have had also the student name, the student homework assignments. I could have put all of that in there, but then this wouldn't work because I'd have to repeat that student name every time I had an email from that student. As we're going to see, this is non-normalized. This is not a good method of doing this. So what I want is I want to have a way of only storing this information once, but to be able to use it on my other table, I will do that through a relationship. So here I've got my primary key, I've got student number. I wish to create a relationship with this other unique table, the email table. How do I do this? I introduce the concept of a foreign key. And just as the name says, this is a foreign key. This means it is foreign to the table it's going to reside in. So my email table is going to consist of, again, a primary key, some unique identifier. I'm going to store the date of the email and what the message was. And now how do I relate that to the student that sent it? I'm going to introduce into here a foreign key. Student number has nothing to do with the message itself or the date the email was sent. This is foreign to this table. But by putting this foreign key in there, I can now look at this and I can ask you, looking at this data here, can you tell me what was the date that Sui Lao sent me an email? If the relationship here is concrete, if there is a steady relationship between these two tables, you'll be able to tell me what date did Sui Lao send me an email. And again, this is the type of question you're going to be seeing on a quiz and an exam. Can you do this? Before I turn around and give the answer, stop for a second, look at the screen, and tell me what's the date. What? Yes, correct. Very good. Thank you. Yes, the date was March 15th, 2007. How did we do that? How did we know? We went and we looked at the primary key value, 1644. We went to this table and looked at the foreign key there and said, does that data show up anywhere in this table? And sure enough, it showed up there in this row. This means that this is the email that was sent by this student. So then all I did is went down and looked at the date, and sure enough, I was able to retrieve the date that Sui Lao sent me an email because this is a relational database. There's what I mean by primary key and foreign key and an implicit relationship. There is nothing else. There's no actual lines. The computer doesn't draw lines inside of itself. These are independent tables. The relationship is implicit. It is implied through the use of this primary key, foreign key matchup. Looking at this, I have the table of student table, and I have office visits. And again, same thing. I have my primary key, the student number, and then what I have here is my office visit table. It has its own primary key. I need to identify each of these rows uniquely. That's why each table has a primary key, and then it has its data, the date of that office visit, and what notes I made on it. Now again, I need to associate this with a student. It is inefficient to always put down the student's name next to this and other data I might need. So what I want to do is associate this with the other table. I do this through the relationship. It's an implied relationship using a primary foreign key matchup. So what do is I take the primary key from that table, and I make it the foreign key of this. This data here is foreign to this table. It is the foreign key, but because it is there, I can now turn around and ask you again, looking at all of this, when did Jeffrey Tam come and visit me? And what was the purpose of the visit? Again, giving you a second. I think by now you all have this. What was the date of Jeffrey Tam's visit? So let me go and look, make sure that I picked the right one. And sure enough, it was February 17th, 2007. It's as simple as that. That's what a relational database is. Now again, simple to look at, but it takes some time and thinking in order to create a relational database. This is what we're doing, which is why we're going to be first doing our diagrams. In our diagrams, we're going to prototype this before we build it because we're going to be doing all the heavy lifting in that section. By doing this and designing it ahead of time, we will know what foreign key is going to be put in from what primary key in the tables we want the relationships with. So what is metadata? Besides being a cool word, and it's okay, kind of neat, what do we mean by metadata? Because every database has metadata. Metadata, very simply, this is just data about data. The best way of defining metadata is data about the data we're using. And okay, now I know that sounds a little confusing too. But remember, databases are self-describing. You're able to look at a database, and by looking at this and what's in there, that tells you what you need to know about the operation of that mechanism. This is a collection of integrated records, and it contains within itself a description of its contents. If I was to ask you how many tables are in this database, you'd be able to go and look and see that. If I want to know information about those tables, that's the metadata. There is data about those data tables. So here we're looking at the metadata, data that describes the data. This makes databases useful and more useful than a spreadsheet. This is how we're able to use multiple themes as opposed to a single theme like a spreadsheet does. This makes the database even easier to use. Without metadata, we could not have relational databases. So looking at this in Access, as we're going to see the metadata, then we can bring up the properties of a table. We bring up the properties of a table. This is going to give us the field names, and so we know what the name of each of the field is, but then what we're going to have is the metadata about each of those fields. The metadata, for example, is the data type. We're looking at something like student number, and we're going to store that as a number, although in reality you never will, as we will discuss later. But something like a message, we're going to store that as a text. Date will be stored as a date. When we've got a student name, the first name and last name, those would be, again, text fields. Looking at this, once we have the metadata and the data type, you're going to see that the property list changes. And we're going to be able to store things like, if it's a date, how do we wish this date going to be represented to the screen? Is there going to be a default value? Looking at this, we start looking at our ER diagrams and translating them into databases. This is the metadata we're going to be using for that. Now I know that was a lot of information, but that ends part 2 of our discussion of databases.